and welcome to the session on DevOps Environment in various organizations that adopt DevOps as a software development and delivery methodology. We will look at how organizations should set up a DevOps environment in terms of technologies, tools, and also for their teams culturally, what changes they should bring within the organization to have a successful DevOps transition, and what are the various challenges that organizations can run into when bringing about these DevOps environment changes. For an organization, DevOps adoption not only means a lot of tools and software for the team to learn and understand. Of course, that is there. It also does not mean you begin to do your deployments in a cloud environment. That is just one part of adopting DevOps. DevOps option not only means that you do your deployments in a Docker containers. Certainly, that is one way of doing your development and deployment. And DevOps in adoption not only means that your dev and operations now collaborate better. Of course, all of that is required for you to be technology upgraded and tools upgraded. However, apart from this, there are a lot of cultural changes within the organization, within the entire organization, and not just the development teams and your operation teams. To understand this better, it is important to learn that DevOps isn't something you do. It is something that you believe as an organization, which in turn drives you to do things that drive your core business. If you believe following DevOps tools, following DevOps best practices will give a boost to your business, will impact your return on investment, would affect your bottom line, then that is how you begin to do things. DevOps is a very different philosophy than how we used to do projects earlier. In the past, QA and operation were usually separate teams from the development team within the IT. Code would go from a developer to QA and back and forth till QA passed all the tests, and then operation worked on deploying the code. The intent of having these gates between different roads was basically to make sure that nobody did anything that wasn't supposed to be done, like deploying an unapproved or untested code into production. While this was implemented or put in place with all the good intent, the end result of this led to developers becoming lazy, knowing that another team, which is the QA team, is now going to check their work. So they concentrated less and less on producing quality code, because they knew even if they missed something, or if they poorly coded something, there is an entire team dedicated to find any mistakes they did. Even while doing unit testing, many times a developer would not even do unit testing, just push the code into testing, knowing that there are hundreds of test cases that are going to run, so invariably, if they made any mistake, it will get caught. QA in turn had to start taking their job more seriously, and organizations started to invest heavily in QA automation, because they not only had to do the functional testing, but many ways they had to even find flaws within the unit testing or any poorly coded coding projects that the developers had followed. Since the developers were doing their job less well, the organization had to spend a lot of time and money on testing. This also led to the developer versus QA approach not being very beneficial for end software quality, because if there are fundamental issues with the code written, how much ever you can test, you will not be able to find out all the issues and resolve them in the time that you have for your project to be completed, and also be able to produce a quality deliverable. Unfortunately, the organization's compensation and reward systems also heavily supported this approach, and this also led to inter-team rivalry, making for a very unpleasant and unproductive workspace. Operation, in turn, made mistakes because they did not write the code. Developers were laid back and had little motivation to write code that was easy to deploy, manage, or monitor. Developers basically threw the code over the wall, and then operations just had to deal with it. This caused further inter-team rivalry between development and operations team because everyone in the organization was appraised on the project delivery and how quickly they were able to deliver it, and how few issues there were. So, more issues, more problems by operations men, their appraisals were not good, and developers had little reason to start writing better code because QA was being questioned for not doing sufficient testing before the project release went for production deployment. Software development and delivery teams were all responsible to have the same goal, delivering high-quality software and services to your end customer. So we are all supposed to be in this together. All the teams, your business, your development, your testing, your operations, your stakeholders. It is not a matter of throwing things over the wall and dusting your hands off that my job is done, so now it is all up to you to know how to take it into production. DevOps, on the other hand, envisions application and software delivery that can be constantly pushed in small incremental updates to the end users with minimum of operational overhead. Small releases are not only easier to code and test, but also far safer to push into production on an ongoing basis. But in order for all of that to happen, everyone has to work together. In a DevOps environment, this is how things work. Developers write the code. They check their code into a source code repository. Repository's current code is pooled and built into a software application. All the automated tests created by developers are run, including integration tests and even user acceptance tests. If tests succeed, then the build gets deployed automatically into production, and your end user feedback is collected, which goes into the next iteration of the development cycle, and you go on repeating these steps, so on and so forth. In a DevOps environment, many parts of this can be automated. All these steps that we just saw. Parts like user acceptance testing can perhaps still be done manually. The objective here is to create as few barriers as possible between the developer and the end user. That certainly does not mean there are no checks. That is where testing comes in. However, you don't put one part of the IT team in charge of stopping another part of the IT team from doing stupid things. You need the ability to automatically and constantly spin up software environments, creating a variety of authorized roles within your development team to start environments on demand. It could be a developer spinning up a development test environment several times during the day. Environments that are spun up must reflect the final production environment. If you as an organization cannot come to terms with allowing your developers to automate this process, then DevOps is something that you are still not ready for. Newer configuration management tools, like your Microsoft's desired state, configuration, Chef, Salt, Puppet, and Ansible, let you do all of this. Containerization is another technology that can work as it abstracts a number of environment variables, reducing variations and complexity between environments. By doing this, any environment, whether you are development, test, or production, the application runs exactly the same all the time. You are much less likely to run into problems, moving the code from one environment to another. If by adopting all this automation and tooling, you are still making one team a bottleneck to move from one step of checking in your code into source code repository, to triggering a build on that, and that really doesn't help you with the automation, because now you have in a way created manual hurdles, or team hurdles, just to trigger these automated tasks. You need to provide developers with a managed set of capabilities. Developers working on a project should be able to spin up a virtual environment without anyone else's intervention. They should be able to recycle environments, even delete and recreate anytime they want. They do not get to change their environment specifications on their own or get free rein of yet-to-be-created virtualization infrastructure. So, these could be some of the very fundamental changes that you also need to implement on the ground when adopting DevOps to build an environment of your people, of your teams that can support DevOps. You need to have the confidence and trust in your teams to allow them to do all of these automated tasks. If trust is an issue, or the capabilities of your team members is an issue, then you have a separate problem that needs to be solved. But without all this going hand in hand with latest tools and technology, you will not be able to benefit from DevOps only as much. You will, unfortunately, not be able to get the full benefit of adopting DevOps.
Hey, want to become an expert in cloud computing? Then subscribe to Simplilearn's channel and click here to watch more such videos. To nerd up and get certified in cloud computing, click here.